Okay, so 7, 5 was our adding, subtracting, and multiplying, and then the scalar multiple on the matrices. So the first thing you want to do, remember, is check to make sure it can be done, right? So for A, obviously a scalar can be done to any of the matrices. I just want to take the 2 and multiply it in on A. So 2 is going to go to all 4 parts here. And I get negative 6, 10, 14, and 8. For 2, it says negative 3b, so we're doing negative 3 times all the parts of b. 9, negative 18, negative 6, and positive 3. For 3, it says a plus b, so the plus and the minus is the ones that you want to check. What's the rule? When can it not be done? If it's different dimensions. Good. So are these different dimensions? No, which means they can be done, right? So negative 3 plus a negative 3 is negative 6.
The easiest warm-up ever. Impossible.
You're right. 5 plus 6, 11. 7 plus 2, 9. And 4 minus 1 is 3. Maybe you'll get lucky and 1 on your test will be like that. All right, number 2. It's not a typo. It says 2a minus 3a. You can use the same matrix twice. So the 2a was already done. That's this one. And then the 3a, if I multiply the 3 in, I'd get negative 9, 15, 21, and 12. And then I'm subtracting that pink one minus the purple. So you have to remember to change the signs. If you had distributed a negative 3 on A, then I could have added, but I did the positive, so I'm going to subtract. So negative 6 minus a negative 9 becomes negative 6 plus 9, which is 3. 10 minus 15 becomes negative 5. 14 minus 21 becomes negative 7. And 8 minus 12 is negative 4. And then 5 is A times B. So now we're doing multiplication. The rule on multiplication, if it's a 2 by 2 and a 2 by 2, remember, is check the middle 2 match. Obviously, these match. The outer 2 is the result. So I know I'm going to get a 2 by 2 matrix. I make my little square. This would be row 1, column 1, row 1, column 2, row 2, column 1, and row 2, column 2. So the first thing I'm doing is row 1, and I'm going to do it by column 1 first. So negative 3 times, let me get a different color so it's easier to see on the blue. Negative 3 times negative 3 plus 5 times 2, 9 plus 10, which is 19. Then I go to column 2. So still row 1, column 2, negative 3 times 6 plus 5 times negative 1, negative 18 minus 5, negative 23. Then I go row 2. So row 2 is the 7, 4. First I pair it with column 1. And I get 7 times negative 3 plus 4 times 2, negative 21 plus 8, which is negative 13. And then I do row 2, column 2, which is 7 times 6 plus 4 times negative 1, 42 minus 4, which is 38. So my solution is just 19, negative 23, negative 13, and 38. Now the math there is simple, but mistakes are made when you're either trying to do things in your head or you're rushing through it or just silly mistakes. So please be so careful on these kinds of questions. Everybody was good on homework?
Number 3. I kept on marking it like I saw.
Okay, so now we're going to move into 7-6. 7-6 is called the inverse of a square matrix, okay? So we're going to learn how to do the inverse. And a square matrix means the same number of rows as the same number of columns. So a square matrix is a 2 by 2 or a 3 by 3 or a 4 by 4, those kinds of things. We're just going to focus on how to find the inverse of a 2 by 2, okay? I'm going to tell you how you can get a 3 by 3 because you'll figure that out, but it is a much longer process. So first of all, how do I know two things are the inverses of each other? Okay, if I have two matrices, one in this case is called A, the other inverse to that would be a to the negative 1. So remember inverse, we do that little negative 1, right? Like the inverse of sine is sine negative 1. That's inverse, okay? That's just the name. So if I have two matrices that are inverses of each other, then when I multiply them together, the result is 1, 0, 0, 1. So if I did a times its inverse, a times a to the negative 1, I'd get the pattern of 1, 0, 0, 1. And if I did a to the negative 1 times a, because remember order is important, I would also get 1, 0, 0, 1. So when you find the product of those two matrices, the result should be that reduced row echelon. So 1, 0, 0, 1. If it was a 3 by 3 and a 3 by 3, I'd get 1, 0, 0, 0, 1, 0, 0, 0, 1. So the left side of my reduced row echelon. The first kinds of questions actually say show, right? If B is the inverse of A, then, sorry, this is what I just said. If B is the inverse of A, then A times B and B times A would result in that same pattern. So when we get to example 1, it says show that B is the inverse of A. This is like, I know what the work should be, I just have to show the work. So I'm going to do A times B, and then I'm going to do B times A. So in order to show that something is the inverse, I have to multiply them out in both directions and show that my answer would be 1, 0, 0, 1. So I'm going to start with A times B. This is row 1, column 1. 2 times negative 1, negative 2, negative 1 times negative 3, positive 3, and the answer there is 1. Then row 1, column 2, 2 times negative 1, negative 2, negative 1 times negative 2, positive 2, and there's my 0. And then I go to row 2. Row 2 and column 1 first. Negative 3 times negative 1 plus 1 times negative 3. 3 minus 3, which is 0. And then row 2, column 2, negative 3 times negative 1 plus 1 times negative 2. 3 minus 2, which is 1. So again, here your work is your answer. You are showing that that's an inverse, which means it would have to be in the 1, 0, 0, 1 pattern. Then B times A. So for me, we train our brains to see things left and right so much that I have a hard time switching these. I literally rewrite A next to B. You don't have to do this. This is like what helps my brain, so feel free to do it if it also helps yours. But I have a hard time going right to left. So now I'm going row 1, column 1. Negative 1 times 2 plus negative 1 times negative 3, and I get negative 2 plus 3, which is 1. Row 1, column 2. Negative 1 times negative 1 plus negative 1 times 1, and I get 1 minus 1, which is 0. Now I go row 2, column 1. Negative 3 times 2 plus negative 2 times negative 3. Negative 6 plus 6, which is 0. And the last one, row 2, column 2. Negative 3 times negative 1 plus negative 2 times 1. 3 minus 2, which is 1. So on a question like this, your work is your answer. If you don't get that pattern and it literally says it is the inverse, then obviously something's wrong. A variation of this question is B an inverse to A? And that you check both A times B and B times A. If they're both 1, 0, 0, 1, then it's yes. And if they're not both 1, 0, 0, 1, then it's no. So that's two different kinds of questions. This one says it already is, so we know what the pattern should be. We just have to show the work. The other kind, you're testing to see if that's the pattern, so the answer is a yes or a no. Questions on this one? All right, I'm just going to say what would happen here. We're not going to work all the way through this, but what's different between this and the last one? There's a 1/2, so what do you have to do first? Distribute that 1/2 to each of these. So I would get -2, +1, 3/2, and -1/2. But then I do exactly the same thing I just did. Do we need to work this through? Do you need me to work this through? You're okay. We're okay. Yeah. So if there's a scalar, just make sure you multiply that first and then do your A times B, and you should get 1, 0, 0, 1, and then your B times A, and you should get 1, 0, 0, 1. Here comes the fun, yes? Because this is now a 3 by 3. So a 3 by 3 times a 3 by 3 results in a 3 by 3. So it's like our little tic-tac-toe board. So we go row 1, column 1. I do 2 times 1 plus -17 times 2 plus 11 times 3. And I get 2 minus 34 plus 33, which is -32 plus 33, which is 1. Then I go row 1, column 2. 2 times 1 plus -17 times 4 plus 11 times 6. 2 minus 68 plus 66 is -66 plus 66, which is 0. Then I go row 1, column 3. 2 times 2 plus -17 times -3 plus 11 times -5. 4 plus 51 minus 55. 55 minus 55, which is 0. Then I go row 2. Start with column 1. So -1 times 1 plus 11 times 2 plus -7 times 3. -1 plus 22 minus 21. 21 minus 21, which is 0. Then I go row 2, column 2. -1 times 1 plus 11 times 4 plus -7 times 6. -1, positive 44 minus 42. 43 minus 42, which is 1. Row 2, column 3. -1 times 2 plus 11 times -3 plus -7 times -5, -2, -33, positive 35, -35 plus 35, and that's 0. Now I go row 3. Start with column 1. So 0, 1 plus 3 times 2 plus -2 times 3, 0 plus 6 minus 6, and that's 0. Row 3, column 2, 0, 1, 3, 4, -2 times 6, 0, 12, minus 12, 0. And the last one, 0 times 2 plus 3 times -3 plus -2 times -5, 0, minus 9 plus 10, positive 1. Am I done? No, we have to do the other way. I'm not going to do it because guess what? The answer's going to be right. Just know that in order to prove it, you have to do it both ways. Look at your face. Yes, you have to do it both ways.
So if one way is correct, does that mean the other way is correct?
No. This, yes, because it literally says in the directions, show that it's the inverse. It's already telling you it's the inverse. So yes, of course, these answers are going to be 1, 0, 0, like all that. But if it says, is B the inverse to A times B might give you the right pattern, but B times A does not have to give you the right pattern. Remember, they're not the same. I can't switch the order of the letters and it necessarily be the same. So the show means you have to show the work both times.
When we switch them, we'd be doing like row 1 of B.
Yeah, so I would like take this again because my brain is so trained to go right to left or left to right. I would rewrite A over here because I've done it the other way and I screw it up. Like I just know me. I know that I will mess it up at some point because I'm so used to going row, then column, then row, then column. So if I would recommend you do the same. If you don't need to, fine. Your brain is different from mine. That's totally fine. But I know for me, I need to rewrite it. So I'd be doing the row 1 here, row 1, row 1, then column 1, then row 1, then column 2, then row 1, then column 3, right? Yes, super tedious. The good thing is you're practicing your multiplication and you don't have to do it a lot. Okay? Questions on showing that they're the inverse, or again, if it said, is it the inverse? Then we would make sure that pattern's the same. Okay, then comes actually finding the inverse. So I'm going to teach you 2 methods to doing it, okay? The first is this it looks like a different language to me. This nonsense, right? So this says basically, if I take my inverse, so let's say my matrix is A, and I want to find the inverse. I'm going to write my A, whatever that matrix is, so let's say it's 1, 2, 3, 4, for example, right? I'm going to write that just like I would in terms of like not having the full matrix, just rewrite it. And then next to it, I'm going to write the goal if it was the inverse, which is 1, 0, 0, 1. And then I am going to perform row operations on this to get this side to be in this pattern. So go back to your Gaussian elimination back substitution and your Gauss-Jordan. How would I get this to be 1, 0, 0, 1? Everything you do to this part of the row, though, has to be done to that part. So what's going to happen is you're changing the left side to get it to be what you want to, and in the process, you're changing the right side. And when you are done, when the left side becomes 1, 0, 0, 1, whatever is in these 4 squares is your inverse. So again, I'm going to teach you 2 methods. This is one of them. And this works on a 2x2 and a 3x3. The shortcut that I'm going to teach you after this only works on a 2x2. So that's why I'm going to teach you both. So the question would simply just look like this. Find the inverse to A. So the first thing I'm going to do is rewrite this. 2, -1, -3, 1. And the pattern I want next to it, which is 1, 0, 0, 1. Now I want to change this side of my matrix so that that pattern is 1, 0, 0, 1. What could I do? Try to go in the pattern that we're used to. How do I get a 1 here? I can multiply by a half. Anything else? Oh, say that again. I'm sorry. You're so soft.
Are you trying to get it to look like the other side?
Yes.
You can add row 2 by row 1 then.
So it's complicated, but if I want to avoid fractions, I can change the signs, right? And I can add them. I could change both signs of both rows and then add them, and it would give me the 1. So you could do either way, okay? If you're a fraction person, if it doesn't scare you, go for the first way. If fractions are where you know, like, I don't know, like God, you were absent the day God gave out the fraction gene, then try to avoid it if you can. You can do it the other way. So let's just say we do the fraction one. So 1/2, right? So I get 1, -1/2, 1, 0, -3, 1, 0, 1. Not horrible. This should be 1/2, except No, this should be a half. Whatever you do to the left, you have to do to the right. All the way across. Here, 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 here. All right, now I need a 0 here. There's only one way to do it.
Multiply row 1 by 3.
3 row 1 plus row 2. 3 negative 3 halves. 3 halves 0 plus negative 3 1 0 1.
Oh, it's only the row that you add the 1 half.
Right, just that single row. Yep. So I get 0. This is 2 over 2. So negative 3 over 2 plus 2 over 2 is negative 1 half. 3 over 2 and 1. And that takes the place of row 2. Now what? I need a 1 here and I need a 0 here. And it doesn't matter which order I do that, because if I do the 1 before the 0, I end up having to multiply again by the half anyways. So how could I get the 0?
Negative row 2 plus row 1.
Okay, so negative R2 plus R1, change the signs of this, and I get 0, 1 half, negative 3 halves, negative 1, oh that's really hard to see, sorry, 0, 1 half, negative 3 halves, and negative 1, plus 1, negative a half, 1 half, and 0. 1, 0, that would be 2 halves, which is 1, and negative 1. So that replace row 1, 1, 0, 1, negative 1, 0, negative a half, 3 halves, 1. How do I get a 1 here? Good. Multiply by negative 2. And I get 1, 0, 1, negative 1, 0, 1, negative 2 here would be negative 3, and then negative 2. So the left side of my matrix is now the part that I wanted to get. The right side of the matrix is your answer. So this would be a negative 1. And again, I teach you this method because the shortcut I'm about to teach you does not work on a 3 by 3. If this was a 3 by 3, I'd have to work it so that it's 1, 0, 0, 0, 1, 0, 0, 0, 1 all the way through, like reduced row echelon, and then the right side of that's the inverse. All right, you try it. I'll go back.
Can you go back one?
All right, so you didn't have to do it exactly like this, but I chose to get that 1 first. I did -2 times the bottom row and add it to the top row. 1, -8, 1, -2, and then I wanted to get the 0 where the 2 was, this one. So I multiplied row 1 by -2, added it, and got 0, 19, -2, 5. Then I have this matrix, and I want to get 0, or I actually got the 1 where the 19 is. I multiplied by 1/19. Sometimes there's going to be fractions and you can't avoid it. It's not like before where I was like, oh, I'm going to give you nice round whole numbers. It's not going to happen this time. So you're going to have fractions sometimes you can't avoid. So then I multiplied row 2 by 8 and added it to row 1, canceling out the second 0. And I got 1, 0, 0, 1 equals, and the answer, which is 3/19, 2/19, -2/19, and 5/19. Questions on that? Okay, ready? I'm going to make your life easier. So that again, if you do an inverse of a 3 by 3, which I'm not going to make you do, you're welcome. That's your COVID perk. You're not going to have time to do it. Okay? You would have to do it the way we just did it. But a 2 by 2 can also be done this way. So this is actually using something called the determinant. This is the only time I think your book is weird because it goes out of order. The determinant's actually the next section. So it doesn't name it in this section. In the web assigned directions, it says like use the formula from above, and this is what it means, okay? So if you are given a matrix and it's 2 by 2, it only works on a 2 by 2. I want to stress that. Then you find something called the determinant by multiplying these two terms together, then subtracting from it these two terms. So A times D minus B times C is what we're doing. And again, in next section, we will learn that this is called the determinant. Okay? The very first year I taught this, and it's been a long time, but the first year I taught this, I would draw, like, I would do these and then come back, draw these and then come back and do these. And one of the girls, and I still remember who it is, said that looks like a Jesus fish. So we started to call this the swish or the Jesus fish, okay, but it's the determinant. If you remember that, if you start at the bottom right, you'll always remember the order to go in. And then she's like, if you give the little fish an eye, you remember to subtract. So as cheesy as that is, if it helps you remember, it works, right? So we start at the bottom, we go up with the product. So we multiply these two together first. Remember the I is there, so you subtract the other two next. From that, you're going to get a single number, and that's called the determinant. If we put 1 over that number and we multiply it in onto the matrix after we shift things around, which I'm going to show you in a second, you get the inverse. So I'm going to do 1 over the determinant, which is this, and then I take the original matrix. Now compare the A, B, like compare these letters, erase. Compare these letters to these letters. Notice the A and D have switched location, and the B and the C are the opposite sign. So this sounds like a long process. It will take you 30 seconds once you get the hang of it, and it's so much easier than the 1001. So I switch the A and the D, literally move their positions. I negate or change the sign on the B and the C, and then I multiply in 1 over the determinant, or 1 over the swish, 1 over the Jesus fish, whatever you want to call it. All right, so I start with the determinant. I do 5 times 3, or 3 times 5, minus, bring it back around, 2 times -2. And I get 15 minus a -4, which is 15 plus 4, or 19. That's called the determinant. I do 1 over that times, I switch the positions on the A and the D, so the 3 and the 5 change positions. I change the signs on the -2 and the 2. So we're not switching these, although it looks the same because they're both opposites. Good morning. We're not switching those, we're changing the signs. And then I simply distribute this in 3 over 19, 2 over 19, -2 over 19, and 5 over 19. And that is the inverse to A. So if you look back at the example that we just did, we did this the long way. That takes a heck of a lot less time. And all of these can be checked if you think about it, right? I could multiply, if I have extra time. You could multiply a times -1, and then the reverse and make sure the pattern's 1, 0, 0, 1. So I'm gonna, all right, so if I wanna find the inverse of example 6, I'm gonna go to my matrix menu. I'm gonna go over to edit. Oh, hang on. I'm gonna grab that first one. I'm gonna change this to a 2 by 2 because that's what we're dealing with. I'm gonna type in 5, -2, 2, 3. There's the matrix I started with. Second, quit gets you out of that menu, back to your home screen. I want to pull back matrix A. So I go second, matrix, I go over, nope, I keep on the name, sorry. I hit enter on A. And then the same button that we use for matrix is my inverse button, the x to the -1. I literally just hit that. I hit enter, and it gives me the matrix. And it's super sloppy because those are decimals that don't end and don't repeat. But remember, if I go to the math menu and I click number 1, arrow fractions, it's going to convert those decimals into the fractions that match my answer. Do we see that? Yes? Again, because I'm telling you this, you cannot use your graphing utility on your test. However, if you get frustrated on your homework and you don't know why it's not right, you could check it, okay? Questions for me on anything we talked about today? Sweet. All right, it's literally a 5-question homework. Should not take you very long. Feel free to use the shortcut every time. With the exception of the number 4, it says use the matrix capabilities on your graphing utility to find it. You need to make sure you take a picture of that, okay? And then number 3, you have to do the 1, 0, 0, 0, 1, 0, 0, 0, 1. So it's the 3 by 3. You got to practice that at least once. All right, folks. Have a fantastic weekend. Have a happy Valentine's Day. Enjoy your President's Day off. I know I will. I'm going to try to get your test done. They take forever. Yes, I.